Welcome to our latest video on the topic of fuels. This video is suitable for GCSE students. By the end of this video lesson, you should understand that the combustion of any fuel requires oxygen from the air, and the combustion of both hydrocarbons and alcohols releases energy in addition to making carbon dioxide and water. You should also be able to describe the steps of a simple experiment to determine the energy released by a fuel and be able to calculate energy values from given data. Finally, you should be aware of hydrogen's use as a fuel for rockets and in fuel cells to power cars, and be able to describe its advantages and disadvantages as a fuel. So let's start by defining what we mean by the term fuel. Fuels are substances that we burn in oxygen to release energy. And a reaction that releases energy is said to be exothermic. Now, when a substance burns in oxygen, a combustion reaction takes place. Now, a good fuel is said to have the following characteristics. It should be easy to ignite and keep alight. It should not produce much ash, smoke, or polluting gases. It should release a lot of energy per gram or kilogram. It should be easy to store and transport, and be cheap to produce and use. Now, in this video, we're going to look at some of the fuels we've already come across in this topic, such as ethanol and alkanes, and we're also going to look at some alternative fuels, such as hydrogen. Now, in previous videos, we've learned that alkanes are excellent fuels. Now, alkanes are hydrocarbons, which means they consist of hydrogen and carbon only. And when alkanes burn in oxygen, they produce carbon dioxide and water. In addition to this, the reaction is exothermic, and that's why alkanes are used as fuels. Now, there are lots of examples of this. For example, methane is used in gas fires, gas cookers, and in Bunsen burners. Butane and propane are found in camping gas and are used in barbecues. Butane is used in cigarette lighters, and octane is a main constituent of petrol. Now, it's also important that you're aware of the environmental impact of burning hydrocarbons. Now, when you burn a hydrocarbon, it reacts with oxygen and forms carbon dioxide and water along with energy. The reaction is exothermic. However, the carbon dioxide is a greenhouse gas, which means that it traps heat and causes the Earth's temperature to rise. Now, this ultimately is global warming, and global warming has a massive impact on our planet, from ice caps melting to droughts and extreme weather conditions, and therefore it's very important that as a world we reduce our reliance on oil, we stop burning fossil fuels, and we reduce CO2 emissions. Now, in our previous video on alcohols, we learnt that bioethanol, made from fermentation of sugar from sugarcane, is an important fuel in countries such as Brazil. Now, alcohols are often used as fuels because when you burn them, they release lots of energy. And alcohols react with oxygen on burning to produce carbon dioxide and water alongside this energy. So here's an equation to represent this. Ethanol plus oxygen goes to carbon dioxide and water. Now, the advantages of bioethanol is it's made from sugarcane, which is a plant, and it's a renewable energy source. And secondly, even though carbon dioxide is produced when the alcohol burns, and carbon dioxide is a greenhouse gas, plants take in carbon dioxide, so the process is considered to be carbon neutral. Because although you're burning ethanol, which is producing carbon dioxide, you are growing sugarcane to make the ethanol, and the sugarcane is a plant, and that takes in carbon dioxide. Now, the disadvantages of using bioethanol is that it's land intensive to grow sugarcane. It takes a lot of farmland to grow sugarcane to make ethanol. And if you devote a lot of farmland to growing sugarcane, less is available to actually grow food crops to feed your population. So being land intensive is a disadvantage of bioethanol. And ethanol is less efficient than fuels such as petrol, and this means that there's less energy produced if you burn the same amount of ethanol compared to petrol. And the third disadvantage is you need a specific climate to grow sugarcane. Not every country has this climate. Now, it's very common at GCSE for students to be asked to describe the advantages and disadvantages of using bioethanol as a fuel. Now, in our previous videos, we've discussed the environmental impact of burning hydrocarbons, alcohols, and fossil fuels. All of these produce carbon dioxide when you burn them, and carbon dioxide is a greenhouse gas which causes the earth to warm up. It causes global warming. Our previous videos have also discussed the fact that fossil fuels are non-renewable. They're a finite resource. Once fossil fuels have run out, they cannot be replaced. Fossil fuels takes millions of years to form. So there is a great urgency to look for alternatives to fossil fuels. We need to protect our environment, and we have to look for alternatives because fossil fuels will not be there forever. One alternative to using fossil fuels could be hydrogen. Now, hydrogen is used in rocket fuel and in hydrogen fuel cells to power cars. Now, in the next section of this video, we're going to look at hydrogen fuel cells, and we're also going to look at the advantages and disadvantages of using hydrogen as a fuel. So let's start with the advantages. Well, one of the main advantages of using hydrogen compared to, say, using hydrocarbons is that it's a renewable energy source, because hydrogen is made from water and it's renewable. It's not going to run out. So that's a major advantage. It's a renewable energy source. And the second advantage is that it produces only water as your waste product when it burns. Hydrogen plus oxygen makes water. So you're not making carbon dioxide, you're not contributing to global warming, and you are not increasing the greenhouse effect. There's also no sulfur present, so you're not causing acid rain either. So the first disadvantage of using hydrogen as a fuel is the fact that it requires large amounts of electricity to produce hydrogen from water in a process called electrolysis. And you have to consider where this electricity is going to come from. If it's being generated from fossil fuels, this is going against the green aspect of using hydrogen in the first place. So that's the first disadvantage, the fact that it requires large amounts of electricity to actually produce the hydrogen from water by electrolysis in the first place. Now, the second disadvantage of using hydrogen as a fuel is the difficulty that exists with storing hydrogen. Storage requires bulky and heavy pressurized containers and is potentially hazardous because hydrogen forms an explosive mixture with the air. Now, another drawback to using hydrogen as a fuel is the fact that currently in the UK there's not the network of service stations that allow you to fill up your car, your bus, your lorry with hydrogen. And this lack of a network of service stations is going to prevent hydrogen taking off as an alternative fuel to, say, petrol or diesel, unless we can overcome this. Now, the following slide shows how hydrogen fuel cells work. Now, many hydrogen-powered vehicles have fuel cells, and these work a little bit like batteries because the hydrogen gas flows into the fuel cell, so does air, and inside the fuel cell, the hydrogen reacts with oxygen to make water. Now, this process produces the electricity, which powers a motor, which drives the car. Notice that out of the exhaust comes water vapor, and that's the only product from this process. So that is a real advantage of using hydrogen fuel cells, because you're not generating carbon dioxide, you're just generating water, and water is present in the atmosphere already. Now, some hydrogen-powered cars and buses have normal internal combustion engines. Hydrogen burns in these engines just like petrol or diesel, and the product of the burning reaction is water. Now, in hydrogen-fueled buses and cars, hydrogen reacts with oxygen. The reaction has one product, water. Hydrogen plus oxygen makes water, and this leaves through the exhaust pipe as a cloud of water vapour. Now, at the moment, hydrogen-powered cars are very expensive, and some people are very worried that they'll never be cheap enough for ordinary consumers to afford them. For hydrogen to take off as a real alternative to petrol and diesel, the price of hydrogen-powered vehicles must come down. For most people, the cost of a hydrogen-powered car is too much. The high cost of hydrogen-powered vehicles, together with a lack of a network to actually refuel your cars, is the main reasons why there are still not that many hydrogen-powered vehicles on the roads today. Now, in the next section of this video, we're going to look at an experiment that can be carried out to measure the amount of energy given out on burning a fuel. So this slide shows the apparatus you could use. Now, the experiment works by burning a fuel in a spirit burner. So, for example, we have an alcohol here in the diagram, and when the fuel burns, the energy is released, and this transfers to water that would be in a can or a flask. When the energy is transferred to the water, this causes a temperature rise. So we measure the temperature rise, and we also measure the mass of fuel that we burnt, and we use this information to calculate the energy that has been released by the fuel. Now, it's important that you can describe the steps to carry out this experiment, that you understand the steps in place to maintain a fair test, and that you understand the flaws in this experiment. So the first thing you do is to measure a known volume of water in your conical flask or in your can, whatever you decide to use. So, for example, you could measure 100 centimetres cubed of water. You clamp the flask at a suitable height so the spirit burner can be placed below it, and you record the temperature of the water. Use a thermometer to do this. Now, after measuring the temperature of the water, you then have to measure the mass of the spirit burner containing the fuel. So you would weigh your spirit burner, which contains your fuel, your alcohol or your liquid alkane, whatever you're using in the experiment, and then you place the spirit burner under the conical flask and you light it. Now, the usual method is to allow the spirit burner to heat up the water until the temperature rises about 40 degrees C. So once the temperature has risen by about 40 degrees C, you record this temperature, you extinguish the flame carefully, and then you record the mass of the burner again, because remember, fuel has been burnt, so the mass of the burner is going to be a lot lighter now. Now, to determine the amount of energy released by a fuel, from this experiment you need the following information. You need the mass of water that was in the flask or the can, whatever you decided to use. So if you had 100 centimetres cubed of water, that is 100 grams, because the density of water is 1. Now, the second bit of information you'll need is the temperature rise, and this will be around 40 because you heated up the water until the temperature rose by about 40 degrees C. Now, the last bit of information you need is the mass of fuel burnt. Now, you've recorded the mass of the spirit burner containing the fuel at the beginning of the experiment and after burning. So the difference between these two values gives you the mass of fuel that's burnt. Now, the equation to determine the amount of energy released by a fuel will be given to you in the exam, and we'll discuss this later. However, what we need to discuss now is how we keep the experiment fair, how we carry out a fair test, and the flaws in the experiment, because that is often asked in the exam. Now, if we're going to repeat the experiment to compare the different energy values given out by different fuels, we need to have a fair test. Now, key things to keep it a fair test will be the distance between the flame and the flask. That must be kept the same. Secondly, the length of wick and the type and size of spirit burner needs to be kept the same. If you're going to stir the water in the flask, you need to keep the same amount of stirring, or decide whether you're going to have stirring at all. So those are key things. The actual flask that you use must be the same size and must be made from the same material. So these are all things that you have to consider. And finally, it's essential that the volume of water that's in the flask each time remains constant. Now, this experiment is flawed, despite you doing all this to keep it a fair test, because energy is lost to the surroundings. Not all the energy from burning the fuel that gets released is actually staying in the water and causing the temperature to rise. Lots is being lost to the surroundings. And the actual values you get in this experiment when you calculate it using the formula that they'll give you in the exam are a lot less than the theoretical values you should get. So this experiment is quite good for finding trends if you were comparing one alcohol to another, methanol, ethanol, propanol, butanol, but it's not very good for determining the actual value of energies released, because the values you get are a lot less than the theoretical values that you should get. So now let's look at the equation for working out the amount of energy released by a fuel. So if we were working out the amount of energy released by burning alcohols in a spirit burner, we would need the temperature rise, we would need the mass of each alcohol burnt, and then we'd use this formula. We'd have the mass of water times the temperature rise, and we times it by 4.2 because that is a specific heat capacity that converts degrees C to joules, and we divide it by the mass of the fuel that we burned, the mass of alcohol. So it's mass of water times temperature rise times 4.2, that gives you the energy in joules, and you divide it by the mass of alcohol burnt, because you want your answer in joules per gram. We want the energy released from the alcohol per gram. So now let's look at an example question. So the table has methanol, ethanol and propanol. It has their initial temperature, final temperature. So from this you can work out the temperature rise. We've got the mass of fuel burnt in grams, and we have to calculate the energy given out in joules per gram. So the equation you use is the mass of water. Now we're using the alcohols to heat up 100 grams of water, 100 centimeters cubed. You times it by 4.2, you times it by the temperature rise, and we want the energy given out in joules per gram. So you have to divide it by the grams of fuel burnt. So pause the video, have a go at it, and then we'll take you through the answers. So now let's see how you got on with this question. So if I want to work out the energy given out by methanol, it's 100, because it's 100 grams of water, times 4.2, times the temperature rise, which is 40, because the temperature went up from 20 to 60. And I divide that by the mass of fuel burnt, which is 4, and my answer is 4,200 joules per gram. Now if I look at ethanol, I had 100 grams of water in my flask, or my can. I times it by 4.2, and I times it by 45, because the temperature rise is 45 here. It went from 20 to 65. I divide it by 4, because I had 4 grams of fuel burnt. So my final answer is 4,725 joules per gram. And if I look at propanol, it's 100 times 4.2 times 40, because my temperature rise was 40, and I divide it by 3, the mass of fuel burnt. And my final answer is 5,600 joules per gram. Now you will get this trend if you study methanol, ethanol, propanol, butanol, etc. Because the more carbons in the alcohol, the more energy is released when you burn them. However, as I mentioned previously, the values you obtain experimentally with this experiment are a lot less than the theoretical values, and this is because of heat loss. Heat is lost to the surroundings. So now let's test your understanding of the topics we've discussed in this video with some practice questions. So here's our first practice question. Now this comes in two parts, part A and part B. Read through the question, pause the video, have a go at part A, and then we'll show you part B, and then we'll go through the answers. So here's part B. Once again, read through the question, pause the video, have a go at it, and then we'll go through the answers to part A and part B. So now let's go through the answers to question 1. So part 1A, part 1 says, name the 3 elements that be present in coal to give the product shown in the table. So this would be carbon, sulfur and hydrogen, and I know this because it gives you the main products of burning. So it has to be carbon because you've got carbon dioxide released, because remember, to burn you have oxygen, so carbon and oxygen makes carbon dioxide. You have to have sulfur because it says sulfur dioxide is released. Sulfur plus oxygen makes sulfur dioxide. And there must be hydrogen present in the coal because you get water present. Hydrogen and oxygen make water. So the 3 elements are carbon, sulfur and hydrogen. Now part 2 is asking you what is meant by a finite resource. So if you said it's fuel that cannot be replaced when they're used up, or fuels that will run out, that would get you the mark. So there's 1 mark for that. So now let's look at part B. So B part 1 is asking you to balance the equation for burning hydrogen in air. So you have to put a 2 in front of H2 and a 2 in front of water for the equation to be balanced. If I do that, I have 4 hydrogens on the left, 4 on the right. I have 2 oxygens on the left and 2 oxygens on the right. So there's 1 mark for that. Then it says state the chemical test for hydrogen and give the expected result. Well, you put a lighted splint near the gas and it goes pop. You actually get a squeaky pop, but you didn't need to say squeaky. There's 1 mark for that. And it says give 2 disadvantages of using hydrogen as a fuel. So if you said a large amount of electricity is required to produce hydrogen, that would get you a mark. If you talked about storage being a problem due to its explosive nature, that would get you a mark. Now the examiner will also accept the lack of service stations that exist for vehicles to refuel with hydrogen. So this availability of hydrogen is a problem, and therefore that would be another disadvantage. 1 mark for that if you said that. So here's our second practice question for you to have a go at. Now this comes in 4 parts, A, B, C and D, and part A is on this slide. So read through the question, pause the video, have a go at it, and then we'll look at parts B, C and D. So here's parts B, C and D. Once again, read through the question, pause the video, have a go at it, and then we'll go through the answers to the whole of question 2. So question 2A is asking you to calculate the energy given out in burning 1 gram of butanol. Now, to do this, we have to know the mass of water, where they tell you it's 100 grams. You times that by 4.2, the specific heat capacity. You times it by the temperature rise, which in this case is 30, because it went up from 20 to 50 in the table. And you divide it by the mass of fuel burnt, which is 1, because they tell you it's 1 gram of butanol. And if you do that, 100 times 4.2 times 30 divided by 1, you will get an energy value of 12,600 joules per gram. Now if you had the right method here, so in other words you did 100 times 4.2 times 30 divided by 1, but you got the wrong answer because it was a calculator error, you'd still get 1 mark. But if you've got the right answer with the right method, you get 2 marks. So question 2B is saying apart from using 1 gram of each alcohol and 100 grams of water, give one other step that should be taken to ensure a fair test. So the examiner will accept the following: the same height between the flame and the can, the same wick, the same spirit burner, the same amount of stirring or not stirring. So those would get you a mark. Then they're asking you to compare the experimental and theoretical values and give the main reason for the difference between them. Well, the theoretical values are greater, so there's 1 mark for that than the experimental values. if you said both the theoretical and experimental values have the same trend, in other words, energy released increases as the number of carbons in the alcohol increase, that gets you a mark. And you said that the difference between this is because the loss of heat to the surroundings. That's why the theoretical value is different from the experimental value, is because of heat loss. There's 1 mark for that. So part D is asking you why some people are opposed to the large-scale use of bioethanol as a fuel. Now, for this, you need the disadvantage and you need a consequence of this disadvantage. So you need to expand on this. So one disadvantage is that biofuels are less efficient than traditional fuels like petrol or diesel. And this means they give out lower energy when you burn them. So if you said biofuels have a lower energy output than traditional fuels, that would get you 1 mark. And if you said a consequence of this is that a greater quantity needs to be burned, needs to be consumed, that's why people are concerned, that would get you the 2nd mark. Now an alternative answer to this would be if you said it's land intensive to grow sugarcane. If you said that a lot of land is needed to grow sugarcane, that gets you 1 mark. And therefore, as a consequence of this, less is available to grow food, which could mean that you have food shortages or you have a higher price for food because of this. That would get you the 2nd mark. So those are the 2 possible answers you could say for that question. So here's our 3rd and final question. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So this last question is asking you to give an advantage and disadvantage of using ethanol instead of petrol in cars. And they've given you a table of data to help you with this. So one advantage is that ethanol is made from sugarcane, and that's a renewable source. It won't run out because you can grow more sugarcane. And the table is showing you that there's less carbon dioxide released per dm cubed for the ethanol. So in other words, there's a lower contribution to global warming. So you can get a mark for that. Now, disadvantage is that it's land intensive to grow sugarcane and it's less efficient. So less energy is released per dm cube burnt. So that would be the answers for that. And there's 1 mark each for the advantages and 1 mark each for the disadvantages. So that concludes our video lesson. So after watching this video, you should now understand that the combustion of any fuel requires oxygen from the air, and that combustion of both hydrocarbons and alcohols releases energy in addition to making carbon dioxide and water. You should also be able to describe the steps of a simple experiment to determine the energy released by a fuel and be able to calculate energy values from given data. And finally, you should be aware of hydrogen's use as a fuel for rockets and in fuel cells to power cars, and be able to describe its advantages and disadvantages as a fuel. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @Rada Chemistry.